I'm very happy to welcome you to this quadratic graph, and we have series of questions we are going to solve, and this is part one. And let's start with this equation given, and because that is x squared and the values of x are given as minus 3, and there is a value for y minus 2 for a value for that minus 2, and that is what we are going to do to complete the table, because that is the first thing they say we should do. But remember that 2 is wrong. 2 cannot be there because we already have 2. So let's remove that part of the table and concentrate on the one we have. We can use calculator or anything to do it, but let's start with the first one. When x is minus 3, anywhere I see x, I put minus 3 and solve to find what y is going to be. Okay, because of that minus, I'll put minus here, and this is 2 in bracket. X is minus 3. Remember, that is the first thing in the table. And this is minus 5. Let's find out. Minus 3 all square is 9, and this is minus is plus. 2 times 3 is 6 minus 5, and everything is going to be okay. Let me clean these things here so that you can feel the table very well. Let me clean this color as well. So, and if you check very well, y is going to be 9 plus 6 minus 5 is going to be 10, and so this is 10. Under minus 3 is 10. I am also going to do the same thing under minus 2. So if minus 2 squared minus 2 bracket minus 2 minus 5, what am I going to have? This is 4 plus 4 minus 5. Oh, that should be minus 5. Yeah. And this is 8 minus 5, which is 3. So under minus 2, I have 3. Under 0, if I put x for 0, I put this x for 0, the only thing that will be left is minus 5. So minus 5 will be filled in the other part of the table. And 2 square minus 4 is going to be minus 5 as well. And the table is completed. Okay, let me clean and tidy up my work, and let's go straight to answering few other questions. Okay, now that the table is completed, we are going to look at the next question, which is draw the graph of the relation and using 2 cm to 1 unit on the x-axis, and then 2 cm to 2 units on the y-axis. So these are the two main things I have to consider before going to plot my graph. Now let me tidy up the work first. I will now carry you to the graph, then we start plotting our graph. Okay, let's make few decisions before we start. If y is 10 as the highest value of y and then minus 6 as the lowest value of y, I have to decide where I will draw my horizontal line and vertical line, considering the fact that 10 and minus 6 must enter in this graph, and I must make that decision. Is very important. Now I have to change a new scale because I can't get minus 10 with the old scale. So 2 cm is equal to 2 units. 5 units. This is what I have to work with. The 2 cm equal to 2 units as given by the question will not be able to enter in this my graph. So I have to remove that one, and I'm making this new decision. And this is because the graph I'm using in this my e-platform is not really the kind WAEC is using. Probably, if not, it would have entered. So let's assume I choose this place to be my origin. I want to check if 10 and minus 6 will be able to enter. So, but before that, let me show you what is 1 unit. 1 unit means simply those small lines in 5 places. We'll call them 1 unit. And if it is 10 lines, it becomes 2 centimeter. What I mean is all these small lines, 5 lines is 1 centimeter. 10 lines will be 2 centimeter. It's very important you know that there is nothing special about 2 centimeter, because some students always ask me what is 1 cm or 2 cm. So That is very important. And if you check that, you realize that I will be able to get up to 10 and minus 6 with this scale of 2 cm to 5 units on the y-axis. Let me tidy up this graph, please. And I also have to consider the x-axis. Before that, let me write my unit, my scale, 2 cm to 5 units on the y-axis. I must write it. It gives mark so that the examiner will know the kind of scale you are using to plot your graph. But remember, you must follow the instruction according to the exam body you are writing. And then 2 cm is going to be equal to 1 unit on the x-axis. Let me check if I will be able to have up to x-axis. But let me check. The highest value of x is 4 and the lowest value is minus 3. So I'm going to, if I draw my origin at this point, yes, I will be able to have 1, 2, 3, 4. Correct. It entered to the highest value. It entered. Let me check if minus 3 will be able to enter. Minus 1, minus 2, minus 3. Yes, I'll be able to enter. So drawing my line at that point will help me a lot. So let's draw the line. Where my axis, let me draw the horizontal line. Okay, and my origin is there. This is my origin, 1, 2, 3, 4 on the x-axis, minus 1, minus 2, and minus 3, and this is for the negative x-axis. There is one more condition or very important thing I have to consider before I start plotting. Remember, according to my table, when x is minus 3, y is 10. When x, but before that, let me show you something. If I have 10 lines, is 5 on the vertical axis. One line is going to be 5 divided by 10. Simply say 5 divided by 10, which is 0.5. So each of these small line, this small line, they are all half line. So each line on the vertical axis is representing 0.5, which is half. So if I want to locate 3, what will I do? Let's go. When x is minus 2, I'm going to find 3 at that particular point. So that particular place is 3. If you check very well, each line is half. Just say half, 1, 1.5, 2, 2.5, 3 until you locate that 3. So when x is minus 1, y is supposed to be negative 2. Oh, I'm making mistake. That place is not negative 2. Negative 2 will come to the other side, but I will correct it as we keep going. So when x is 0, y is minus 5. Minus 5 is there. When x is 1, I am noticing that that particular place is having a problem. It's not following the trend. When you make such a mistake, you see that point is not following a trend. When you are following a trend and something is out of a line, know that something is wrong with it. Then you go back and check if your point is very good. That point is out of the trend, as I just showed you. But don't worry, it's going to be corrected. So when x is 1, y is minus 6. So if this is 5, 5.5, 6 will be here. Yes, that is going to be the 6 mark. If x is 2, y is going to be minus 5. So this is 2 and y is going to be minus 5. So yes, now this is minus 5 now. Yes, that is the point, the coordinate. When x is 3, y is 2. So what is 2? Half, 1, 1.5, 2. Yes, 2 is somewhere there. Are you sure? Okay. Now, when x is 4, y is positive 10. Let's go up the line. Okay. Is that 3? Sorry. When x is 4, y is 3. When x is 4, y is 3. Okay, so let me find why that thing is not following the trend. If I put, I think I'm overthinking at this point. So 2 raised and then minus 5. So let's put, if I put 2, I would have just gone to the table, but fine. If x is minus 1, what will my y be? I've already done this before. I just want to be sure. This is 3. Yeah, 5. This is 3 minus 5, which is 3 minus 5, which is minus 2. Okay, so it's minus 2, not at the positive 2. So I will trace it down. Yeah. Let me tidy up the work first. Clean, clean, clean. Okay, now let me also clean this one and go and write it at the right point so that it will enter the trend. Minus 1, 2. Yes, that is the point. So, and many students will always go and look for broom, my dear. You don't need broom. We can use, I'm going to use a freehand sketch. I'm just going to use a freehand sketch. So it's not going to be perfect, but it's going to be good enough. Okay. So we are just going to try. I'm going to start from this place, joining these lines. Oh, that is, are you sure? Can I make it? Okay, fine. Let's keep going. Oh, well, at least something close good. Something close to being good. Let me join this one. Where am I starting? Okay, let me start from here. Oh, no, I'm going off. I've gone off a little. But with your broom, it's coming. Oh, it's having a lot of friction. I have to clean that part. Not looking very good. It's not looking very good, please. Clean this one. Okay, so let's try again with my free hand. So let's join this carefully. Okay, that's a little good. That is good enough. That's good. That's good. No, 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 no. Oh, okay, fine. Then join this one. Okay. Oh my God. I think I'm better. It's better now. It's better. It's better off. Let me extend this part a little. Okay. So this is the graph you are looking for. Okay. Okay. Let me tidy up the rough work. I've cleaned that part. Let me also remember, whenever you plot graph, write the equation on the line, on that curve, so that whenever examiner looks at it, they will know that it is this equation that that gave birth to this parabola, to this curve. All right. So when you are done that one, okay, I've answered question A and question B. I have question C right now to answer. And remember, question C say using the same as is, draw a graph of y equal to 2x minus 1, y equal to 2x minus 1. On this same graph, I should draw this. Remember, this is a straight line graph. Why do I know? Because it is a simple equation. Simple equation does not have a power, or let's should I say, simple equation has a power of just 1. So I'm going to be using the same x values to find my own y. So if I put x as minus 1, what will be my y? My y is going to be minus. Is that correct? No, that's not correct. I will correct it later. So when x is minus 2, okay, let me clean this part. Doing a terrible cleaning here. Oh God. Please remember, if you watched to this point, you need to subscribe, comment, and like. Okay, let's go to next one. Y is equal to 2x minus 1. If y is is minus 2, what is going, if x is minus 2, what is going to be my y? So 2 minus 4, okay, this is minus 5. Okay, here comes a confusion. Minus 5 the first one, minus 5 the second one. It cannot be for a straight line graph, so something might have been wrong in the first one I plotted. So let me clean it. So let me first plot when x is minus 2, y is minus 5. Let me use something different. Okay, let's do for when x is 0, what will be my y? Y is going to be minus 1. So when x is 0, y is minus 1. Minus 1 is just the second smallest line. That is the point. And then I will do the same. I'm going to do the same. When x is 1, y is going to be positive 1. It's going to be positive 1, right? And when x is 2, y is going to be 3, positive 3. So you are seeing the trend is going straight up. So I'm going to do the same until I get to all values of x. Let me join the straight line. Correct. This is the straight line. Oh, a particular point is not on the line. Something must have been wrong with it, and I have to fix it. Check very well. This particular point is not on the line. I have to fix it. First, let me clean it, and then when x is minus 1, why am I struggling with this minus 1 thing? When x is minus 1, y is going to be supposed to be minus 3. So that minus 3 should be that point, okay? That is the straight line, and this is the graph. So the next question is obtain. Okay, we have to go and let me clean this part of the graph, and I also have to write the equation on the straight line in order to identify what kind of. Let's go back to the question and find out in number D. Yes, D is what I am, is where I am right now. You say obtain in the form of a square plus b square, and where a b satisfy the equation, the coordinate of the points of intersection of the graph. To answer that question D, what we are going to do is to equate the straight line equation and the quadratic equation. When we equate the two of them, we have an equation x squared minus 4x minus 2 equal to 0. That is going to be the answer for number the D part of it. But let's do E. Okay, let's head over to our graph. Now, if you look at the straight line and this curve, there is a point where the two of them meet. Wherever the two of them meet is what we have to do in E to answer E. Said from the graph, the root of the equation. So for us to find that point where the straight line and the curve meet at the two particular point and the other side as well, where I am making this point now, these are the two places. If you trace it to x-axis, whatever you get there is going to be the root of the two equations, because this is a kind of solving one quadratic, one linear equation. So you are going to have the x value are going to be 2. And the x value, if you are plotting them in a graph, is a point where the straight line and the curve meet. We'll call it a simultaneous kind of equation where the two of them meet. So when I trace it there, I'm going to find the value of that x when I trace it back to the x-axis. And I'm also going to trace the other side of the graph where the straight line and the curve meet. Very important, that is the where the solution is. So when I trace it down to my x-axis. If you are a WAEC student, remember you must make those dotted lines very visible so that the examiner can see it and award you your mark. So when I trace it down, remember your own, this is the point which is x is going to be minus, okay, let's count. Each line there is 0 0.1, 0 0.2, 0 0.3, 0 0.4. Okay, let's count again. 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8. Minus 0.8 is the first coordinate of x, or the root of the equation, and the other one is 4.1, 4.2, 4.3. 4.8 is at that point. Let me say 4.85 because it's not really at 4.8. So s is going to be 4.85. So these are the two x1 and x2 equation, roots of this equation. Please, thank you very much for this class. Remember, you must always subscribe, come back to this channel because we have almost many parts on this quadratic graph we are going to be looking at. Next time we'll be talking about symmetry and very other part, and then finding the gradient of a curve when a quadratic equation is given. Thank you very much. I still remain VINDAL'S concept. Bye.